All right.
Leaving me. How are you? And you're
Yeah.
I'm bad.
Okay. You need to have special teacher training to touch the pen.
Remember my amazing art that I drew?
Okay.
I need to know how to do math.
I saw that.
This isn't exact every year, but to give you an idea of the breakdown of the AP test, this is very, very close, okay? So here's what you do. You have a total of 45 multiple choice questions. All right? 45 questions. I'm pretty sure, I am sure, 30 on the no calculator part, 15 on the calculator part. Everybody always says the no calculator part rushes because you have to do 30 of them, and the calculator you have like just tons of extra time, but that's how they break that down, okay? They take that score, they multiply it by 1.2, why? To get it out of 54. Right? They get that out of 54. I don't know why. That's just what they do. Okay, then you have 6 FRQ questions, and each FRQ is 9 points.
That's why.
Right? And 6 times 9 is 54, so they're weighting them equal. That's why. Why don't they just use 54 questions? I don't know. But they're weighting it so that multiple choice and FRQ are the same. Okay?
Too many questions.
So then we add that together. So let's say you got. I don't know. What do you guys think? Out of 45 multiple choice questions, how many are you predicting you're going to get right?
12.
45.
Maybe one.
Probably.
Calvin got 38.
30, hopefully a half.
25.
30 is a good goal.
Okay.
35, yeah, I can see that. Let's go with 30. Let's be conservative here, right?
Wait, are we gonna do this and then see what we get?
Sure. Well, I'm just showing you this. When we do practice AP tests, this is how I'm going to score them. On your FRQs, I think I told you if you get about half, you're usually chilling. Half the points. So 4 to 5 points on every problem.
27.
So 27, let's say you're feeling a little good and you get like 30. Your total score would be a 66, and that would be a 5 on the AP test.
Wow.
Really?
What?
I could basically bomb it, get a 26.
Wait, that's almost half.
Scroll up. Wait, Mitchell.
Okay, let's
Mitchell.
say we didn't do so hot on multiple choice. Let's say we only got half the multiple choice questions, which is like 45, 22, all you round down. Okay? Let's say we only got 22 questions right.
What'd you get?
All right, that gives me 26.4. That rounds to 26. Let's say I got 27 there, so half of that.
That's when you run.
And I get 53. Guess what?
53 is
At a score of 53, you're getting a 4. So when I tell you guys that
I'm taking 3.
about half the questions you will pass, seriously, okay? Now,
So you're saying when you get it,
We only have to get a tiny bit more.
FRQs are insanely difficult, but multiple choice make up half the test. So let's try to just get a ridiculous amount of multiple choice questions right, yeah?
wait, if you got 100% of the multiple choice.
Okay, so what we're gonna do is I combined Unit 1 and 2 because they're Unit 1's really short. But what we're gonna do is look at multiple choice questions that have been on previous AP tests. Okay? They release certain AP tests after. They don't release all the multiple choice, but certain ones they'll release the multiple choice and not reuse them. So these are some released questions. Okay? Now, we're going to make some notes as we go through here about what you need to know for limits and stuff like that.
Real quick, Mitchell.
Yeah.
Is that breakdown the same for both tests or just ABs?
I think it's the same, but I will try to find a BC scoring one, but it's about the same, I think. I'm pretty sure. Okay, you guys. We have numeric limits.
You are terrible.
And we have. Okay, listen up. We got numeric limits, we got infinite limits. Okay? My numeric limits are the limit as x approaches a number. Yeah?
Probably.
My infinite limits are as x approaches positive infinity. Okay. Guys, ready? Okay. With numeric limits, step 1, you always plug it in first. Okay? And if you get an answer, great. You're done.
0, 0. 9,
0 over 0, we've discussed a few different ways to do this, right? We've talked about factoring. Yeah, it was mid. We talked about conjugates. We talked about l'hôpital. The hospital. Okay? Then, the last thing, like, can we just say, I'm not going to make this like a bullet point, but you guys know that 0 over a number is just 0. That's fine.
Yeah.
Okay? All right. 0 over 0, factoring, conjugate, l'hôpital. What if we have a number over 0? Do you guys remember what that is?
Undefined.
It's almost always DNE unless it's a one-sided limit because it has an asymptote right there. Okay? But it could be a one-sided limit. We might have to think about the graph or whatever. All right. Infinite limits. Okay, you can look at, this is only if it's a polynomial, right? If it's a polynomial. The degree of the top compared to the degree of the bottom. You guys remember that? If the degree of the top is bigger than the bottom, it goes to positive or negative infinity. The other one is 0. If, I guess I could write more. Okay, degree of the top is bigger than degree bottom. Okay, if degree of the bottom
If I do it
is
all.
bigger than degree of the top, that goes to 0. And if the degree of the top and bottom are equal, we use what?
Coefficients.
Let's go. And we're going to be very careful because if we find an infinite limit and it's infinity over infinity, guess what we're going to do? L'hôpital. So l'hôpital could only be done with 0 over 0 or infinity over infinity. Okay? Are we ready? If I want to make more notes, I'll come over here and make more notes. This is kind of what I'm thinking. Oh, the other thing that will really help you with limits to infinity, I should write this down too, is if you know what the graph of e to the x and ln of x look like. Because if that ever comes up, then you just have to look at the end behavior and it's like super easy. So e to the x looks like this. And so what that tells me is the limit of e to the x to infinity is infinity. But the limit of e to the x to negative infinity is 0. Okay? And I can tell that from the graph. Just where it's going on the right, where it's going on the left. ln looks like this. Okay? So this one, the limit as I approach infinity is also infinity. This one, it's more the limit as I approach 0 goes down to negative infinity. Okay, but if you know what the graphs look like, that can be a little bit helpful. And then we also kind of talked about growth rates, like which of these is growing faster, so we might see some questions like that. Okay? Good? Yeah. What's the point? Oh my gosh, there's so much. It's amazing. It exists in nature, bud. Nature. Okay. There we go. Okay, so let's just kind of go through here. Now, I have a bunch that we're going to do together, and then I have some that you're going to like take home and try, and I'll give you the answers, okay? We'll see what we can get through, right? All right. Now, this is a numerical limit. It says k is a number that is not 0. Now, you guys, when I plug this in, so think about this. This is kind of weird because it's a k instead of a number. But if I plug it in, what do I get? 0 over 0. Okay, cool. Now, what are our options? L'hôpital or factoring. Very good. I will show you both, just so you can see 2 different ways to do it.
I would do factory.
I might too. If I were to do factoring on this, the top is a difference of squares, right?
Yeah.
The bottom I can take out an x. That crosses out.
Yeah.
So it's just x plus k over x. And now when I plug in k, it's k plus k over k.
Which is k over 1.
Which is 2k over k, which is 2. Right?
Yeah.
Okay, let's say instead of factoring, I wanted to do this one by l'hôpital. All right? Now remember, k is a constant. What's the derivative of the top?
2x minus 2k.
Is it 2x minus 2k?
No. No.
K is a constant. It's just 2x. Tricky, right? Yeah, I know. That's why they put variables in there that are constants. What's the derivative of the bottom?
I have a question on the top.
Okay.
Isn't it x plus k is left over, not k plus k?
It is x plus k, but we're still doing the limit as x approaches k. So my work got a little sloppy right here. I skipped a step because I'm being lazy.
Oh.
My most apologies. So it's actually the limit as x approaches k of x plus k over x. And then I put it in. So I skipped a step, my bad. Okay. So with L'Hopital's rule, now when I plug in k, what do I get? Well, on the top I'll get 2 times k. On the bottom I'll get 2 times k minus k. What's 2k minus 1k?
K.
K. And what's 2k divided by k?
2.
Boom. Same answer. So the answer is B, 2. Good? Okay, nice. I love it. All right. Hey guys, if you know what graphs look like, that will be extraordinarily helpful for this question, at least for part 1 and 2. Okay, real quick. Continuous. Continuous means I could draw it without lifting up my pencil. That's all it means, okay? Do you guys know what absolute value of x minus 1 looks like?
It's like
It's a v. That's a v, okay? And it's a v that's right 1. So it's like right there. But anyways, it's still a v. Is that one continuous at x equals 1?
Yes.
Thank you. So that's yes. Okay. E to the x minus 1. Do you guys know what that graph looks like? It's e to the x, and then it's shifted 1 to the right again. So, boop. But whatever, e to the x is always continuous. Now this one is a little annoying, and I have no clue what the graph of ln of e to the x minus 1 is. But
plug in 1.
I think I'm just going to try to plug in 1 and see what happens. Okay?
I'm pretty sure it's 0.
So it's the ln of e to the 0 minus 1. What's e of 0? E to the 0. And it's ln of 0. And what's the ln of 0? Nope.
0.
Doesn't exist. The ln of 1 is 0. Not the ln of 0 is 1. Right?
Same thing.
Yeah. So this is not continuous. It doesn't exist there. So yeah, my answer is going to be 1 and 2 only. Boom. I know you guys remember this. I pray you remember this. This is on every limits test that we're ever given. This question. Okay? Guys, how do I tell if something's continuous? Well, if I plug that into the top, and I plug it in the bottom, I should get the same number. Okay. Talk to me. What happens when I plug 1 into the top? What do I get?
Get something over 0.
Yeah, you get 0 over 0.
Oh, even worse.
0 over 0. What should we do when we get 0 over 0? Factor or L'Hopital? Which do you want to do? Alright, amazing. 2x minus 2 over 1. Now plug it in. 0 over 1, so what does that actually equal?
0.
Great. Which means this one also has to equal 0. But when I plug in 1, I'm plugging for x, not k. K is a constant. K has to be 0. That's it. Because I plugged in the 1 for x. So when you have a piecewise function like this, it's basically saying it's this function, but there's a hole right there. And filling in the hole at the point 1, 0 will fill in that hole on that function. Okay? K is a constant. Remember, it's not x. You got to practice for that. The and in the orchestra. Okay. Let's go, guys. This is more of a thinking question than anything else. I'll give you 4 seconds to put an answer down. Ready? 4, 3, 2, 1. You guys get it? What is it?
Just kidding, I lied.
Oh yeah, that would be.
Okay, you can do L'Hopital's, but way easier. Now, the biggest term on the top is that, okay? Now, if I were to multiply it out, this out first, outside, inside, last, what would the biggest term be?
Negative x squared.
Yeah, it would be like negative x squared and then a bunch of other crap. And my exponents are equal. So I'm going to get coefficients, negative 3. Easy dubs, right?
It's like the math related. It doesn't like seem long.
Oh, you got it.
I was like, I can talk about
Okay, now this looks crazy, and you guys, out of context, so when we start doing practice AP tests, I'm not going to be like, hey, this question is on the limit section, right? They're just going to be all mixed up. It might be a limit, a derivative, an integral, we have no idea. So you're going to see this. Does it say limit anywhere in that question? No. Okay, but it says, consider the function defined pi over 2 to 3 pi over 2 by that for all x, but x can't be pi. If it's continuous, what point should we fill in right there is what it's saying. Okay, now look. If I put in pi, what's the tangent of pi?
0.
Oh, we had trig last week. Let's see.
Well,
1, 0.
sine
We
over
had trig
cos-
Monday.
If it's sine over cosine, 0.
Cosine comma sine.
No, that's
Oh yeah.
for cotangent, right?
I can never remember which is which.
So let's start with sine because that's easier. What's the sine of pi?
I think
0. What's the tangent of pi?
0.
0 because it's sine over cosine.
Oh, so we.
Oh my gosh, 0 over 0. What do we do when we get 0 over 0? L'Hopital.
Be
Exactly.
about to factor that tan out.
Yeah, I'm about to
T times
factor
A
tangent.
times
This is
A.
on the unit 1.
No, but you just do T
Yeah.
times A
Well,
times A.
but they're assuming you still learn L'Hopital. It's just any linear question.
Yeah, it's a bunch of it all cancels out.
All right, my friends. What's the derivative of tangent? Secant squared. Love it. What's the derivative of sine? Cosine. Okay, now I have to now plug in 0.
Isn't cosine negative?
Pi.
That's like
I have to plug in pi. Sorry. Hey, what's up, guys? What's up, guys? Don't tell me.
The entire cup of marinara sauce in the Robitar and then cleaned it up.
Why did
And he didn't know.
Get a couple slices of pizza and grab a seat. Okay.
Staying, I just gave
I
you the
came
packet.
straight from California. Don't judge me.
I'm not judging him. All right, we're very happy you're here, guys.
Pizza.
Isn't cosine negative 1?
Yes.
I took pizza, right?
bro. Yeah.
And I had the pizza in the car. The girl that was driving stomped on the brake and then the
No,
pizza sauce.
it was not her. It was him.
All right.
No!
We gotta
Right?
get out
So
of here.
it's
Let's get out of
all
here.
over the seat. And I'm like, shit. I look at Rena and she's like,
Buddy, I'm recording language.
my bad. And, bro, you gotta clean it up with my feet and there's no stain.
Nah, it wasn't
God
me.
really said, I bless you.
Get out of here, Delano. Love you. See you tomorrow. Bye-bye.
So,
Okay, guys. Okay. Secant of pi. Now we gotta go through this. Cosine of pi is -1, right? What's the secant of pi?
1 over.
1 over -1, which is -1. What's the secant squared of pi? 1. So it's 1 over -1, so it's -1. Okay? So that was a L'Hopital's question, even though it didn't say limit or anything, but it said it has to be continuous. So, all right?
dude, his cam shaft is about to blow.
This is super interesting.
Max is and he has no
Tricky. I got these.
Scroll up like half a millimeter.
So, guys, we can narrow this down a little bit. Okay?
Oh. Yeah.
Let's think about this for a minute. Does it have a vertical asymptote at 0?
The answer is
Bottom equals 0, but it's not a rational function, so let's kind of wait on that. Does it have a horizontal asymptote?
Yes. Because sine's only going to keep going between small, like 0 and 1 or whatever, but the bottom is going to keep getting bigger.
Maybe. And does it have an infinite number of zeros? Okay. I'm going to start with the thing that I know. Zeros are where that equals 0. Right? Okay. So I would solve where does sine x equal 0? And you guys, where does sine x equal 0? An infinite number of times. Sine's on the top. So sine can equal 0 at 0, pi, 2 pi, 3 pi, 4 pi, 5, 6 pi, 7 pi, blah, 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 blah. So yes, it does have an infinite number of zeros. That is definitely true. Okay, zeros are where it equals 0. Now there's a problem with like 0 over 0, but think about it by plugging sine pi over pi. 0 over pi is 0. Sine 2 pi over 2 pi. Sine 3 pi over 3 pi. So it definitely has an infinite number of zeros. Now this tells me I have to narrow down between either 1 or 2 is true. They're not both true. Okay? Let's try something.
Well, if sine...
Yeah, I would start by plugging in 0, but the sine of 0 is 0, so I get 0 over 0.
Sine can only be from -1 to 1, correct?
So can we L'Hopital that?
That's what I was.
You don't need to.
I don't know. Let me just see real quick.
It's not sine. It's not sine. It's cosine.
Yeah? So the limit as I get really, really close, cosine of 0 is 1. The limit as I approach 0 is 1. Now guys, think about this. What's happening when I get 0 over 0, but I can find a limit? What is happening there? No. It's not an asymptote. What's happening when I have 0 over 0? There's a hole there. And since the limit is 1, there's a hole there where that goes to 1. So can there be a vertical asymptote there?
No.
No, because there's a hole there.
The one would be like infinity.
That's a weird. That's
You have to remember that. And I gotta tell you guys something. Look, when you're like sitting here like, I'm never gonna remember that. Look, I've been teaching for a lot of years and teaching calculus specifically and tutoring for a lot of years. And I had to sit and think about this. I don't know it for sure, right? So I had to think, well, how can I tell what's happening at 0? Let me plug in 0. Hey, do you guys know where horizontal asymptotes come from? Nope, that's a vertical asymptote. Limit to infinity and negative infinity. Limits to infinity, that's where they come from. So let's think about this real quick, okay?
That was right.
Did you say limit to infinity?
I said when the derivative equals 0.
No.
I'm
I
saying a
know.
different thing, but looking at me like I know.
So I couldn't tell it was your Abby.
I don't know what you're talking about. I never said that.
Okay, you guys, these two things right here, they tell me end behavior, and end behavior is what horizontal asymptotes is. As you go to the ends of the graph, is it going to go to a specific point, okay? Okay, yeah, now look. As x approaches infinity, do I get infinity over infinity? Okay, can I L'Hopital that? Because I got infinity
No,
over
but
infinity.
sine of infinity is never going to be greater than 1 or less than -1.
Well, right.
Sine, no matter what you plug in, it's only going to be a small number.
And
While
so
x
let's
is going
talk
to be a
about
big
that.
number.
Okay, so I did L'Hopitals and I say, okay, well now it's infinity over 1, so this is approaching infinity. No, I don't like that. Okay, what are you saying, Dallin? You're saying...
Well, if sine can only be from -1 to 1, then no matter what infinity is, we know sine's going to be one of those, or anything in between.
Oh,
But we know
sine's
that-
restricted -1 to 1,
Yeah.
so it's always here, and when we divide by an infinite number, it is going to go
So
to
sine
0.
cannot approach infinity,
Do we
basically.
know it's restricted?
Yes.
Yeah.
Well, I know that the sine graph looks like this, and sine can never be bigger than -1 or 1.
That's actually
That's
really smart, Dal.
tricky. That was really smart, Dal.
I'm impressed.
I'm impressed too. Look, check it out.
Dalin's the new teacher.
No, it's...
Quiet. You know something?
It'll probably, the waves will probably get smaller and smaller.
Yeah.
Miss Mitchell,
Yeah, buddy?
I have no idea.
What?
I don't know what it's for.
Oh, hold on, I'll go back. Now, you wouldn't be allowed to use a calculator, but you guys, right here, there is a hole, but it's approaching 1, and so I could find that by the limit. And then due to, we'll call it Dallas theorem, that it's limited on the top, but it's infinite on the bottom. And we talked about how if we have
Stevens theorem is the most goated theorem of all time.
What is
Something-
Stevens theorem anyway?
If you have like x plus 1 over x minus 1, cross out the x's, cross out the 1s, you get negative over positive.
no Dallas.
So that's Stevens.
All right.
I remember that now.
You cross out the X's and then you
Okay. I think you guys can do this. I think you can do this.
But that actually works for just the idea that if you have a closed system on top and an infinite system on the bottom, you
Yes,
always know.
that is true. Okay, you guys. I want you guys to tell me what's happening with this graph. You're looking for asymptotes, vertical, horizontal, holes. Tell me what's happening. Analyze, if you will, this graph. Okay? Go. I only have cheese left, but I have cheese left. You just sit right here at this table. Go nuts. Okay. Yeah, two back. Yeah, we're gonna roll through these stuff. Okay, so you guys, tell me in words. Let's talk about this. In words, we know a vertical asymptote goes up and down. How do we find what creates a vertical asymptote? Zero where?
On the left.
Zero on the bottom of an equation. For vertical.
Kind of.
Okay.
Wait, what about zero on the top?
Let's summarize this. One. Summary. Ready? Let's summarize this. Vertical asymptote is where you have a zero on the bottom.
Well,
And
the
not.
number a little bit above 0 at least on the bottom. And it's
Okay.
infinity.
Hole. Right, guys? Where do we have a hole? A hole comes when we have 0 over 0. So we have 0, top and bottom. That's a hole.
Well, yeah.
No, an asymptote overrides a hole because you can cross out the 0 over 0 and have an asymptote left over. Asymptote overrides a hole.
Because you have a hole on vertical asymptote.
Right. Okay. Isaac. Horizontal asymptote. How do I find it? Very good. The limit as x approaches positive infinity for the right one, and the limit as x approaches negative infinity for the left one. A lot of times they're the same, but there are some cases where it's different. All right? So that's where we find horizontal asymptotes. Hey guys, what's it called when I have a 0 on the top but not the bottom?
0.
It's called a 0 of the function or an x-intercept or a solution. Go ahead.
Can you demonstrate horizontal asymptotes?
Absolutely. On this question.
Can you show both? Oh, did you craft both of those?
Okay. You guys ready? Okay. We're going to analyze this whole thing. Okay, step one, let me factor this because that looks pretty factorable. Hey, do you guys still suck at factoring or are you getting better? Yeah, you're still trash at factoring, right?
X minus
Here we go.
2, x minus
2xx. Now, I needed to multiply to make a positive 6, but add to make a negative 5.
-6, 1.
So I've got to use,
negative
or sorry, a
one.
positive 3. And that needs to add to make negative 5. So I got to go
-2.
3,
Negative
1,
I'm sorry, what?
boom, boom. Yeah, that's it. Okay?
What are you doing? I'm lost.
What are
I
you
got
doing?
taught a different
All right.
field.
Well, if you know your way, then do your way.
Wait, this,
Hang on one second.
but I didn't get that though.
Wait, how's that? How's that add up to
6.
5?
Hello? Yes.
How does it add up to 5?
She was still long.
How does 3
That's like the worst mistake someone's gonna make.
Oh, you do?
That's 2.
Oh, it's okay. No, it's okay. I know. I made a really bad life decision. But just kidding.
No thanks.
Yes. Look at the front of the car.
Oh, David, he needed me there. Whatever.
Got it?
I did.
Anybody wants to? Oh my gosh.
Okay.
Anybody like Mountain Dew? This last week.
And
Connor, here you go.
All right. Connor will eat it. Okay.
Eat it.
that's all.
Okay. Sorry about that, guys. All right, listen up. Okay, so I have 2xx. Now, with 3, I could put 3, 1. Or I could do 1, 3. And you have to figure out which one it is.
Or you can just give up and find a derivative and hope that it works.
Hey, it'll be 1. Can everyone take a big deep breath for me real quick?
No.
You're stressing me out. 2x minus 3x minus 1.
What's 2x plus 3x?
How do you figure out?
What's a negative plus a negative?
I didn't. I got the wrong.
Wait, a negative plus a plus. It's a negative.
All right, I will. Okay. Woo. Good. Are we okay?
Sure.
Okay. Now look. Hang on. Okay. Hey guys, listen up. Okay, check it out. What's happening at x equals 1?
Mitchell, I think you can do that in algebra. If you just take the derivative of it, top and bottom, you don't got to factor, you don't got to do that. Well, you do that and then you plug in 1, and I got something over 0, which just told me at that point there has to either be a sharp corner or there's not something. And looking at this graph, there's not really going to be a sharp corner, so you can kind of tell that there's.
Yeah, you can check that way. Yes. Okay, hold on. So when I cancel that out, there's a hole at 1. Okay, great. Next. What's happening at 3 over 2?
Okay, we did this earlier. It's 2-0.
There is a vertical asymptote at 3 over 2 because it makes the bottom 0 and not the top. Okay? Okay, now, what are the horizontal asymptotes? So we're looking when x goes to infinity or negative infinity. Now check it out, guys. If I were to multiply this out, what would the biggest term be on the top? X squared. 1x squared. On the bottom, 2x squared. Same degree, top and bottom, we use coefficients. There is a horizontal asymptote at 1/2. Okay? So, does it have, well, first of all, is it continuous at 1? I'm going to say no, that's false because it's got a hole there. What's the matter?
No, you go ahead.
Okay. Does it have a vertical asymptote at 1? No, it does not. Does it have a horizontal asymptote at 1/2? Yes, it does. So the only question that is right is 3.
Wait, so why is there a hole?
Because when I factored it and I could cross something off the top and the bottom, that's where there's a hole. And if I set that equal to 0, that's where there's a hole. Okay?
Mitchell?
Yeah.
So I did it a different way. It was a lot faster, and so I'm trying to figure out.
L'Hopital's?
I was lucky. No, so
what'd
I
you
just
do?
plugged in 1.
Oh, if you plugged in 1 and you got 0 over 0, but then what did you
So
do?
pull at 1, which
Okay,
means
so-
it can't be a vertical asymptote.
Usually yes, but you do have to be careful. Let's say you plugged in 1, you got 0 over 0. You did L'Hopital's, you got 1 over 0. It's actually an asymptote, not a hole. So if there's a hole and an asymptote at the same time, an asymptote overrides a hole.
So
Okay?
even if it looks like a hole, it might be an
It might be an asymptote. For example,
because I just got 0 over 0 and it stopped.
okay,
all
Ready?
asymptotes mean that there has to be a hole.
Looks like a hole to me, right? But the reduced function has an asymptote at 1, so it's not a hole, it's an asymptote. Okay? So asymptotes override holes, so just be kind of careful with that. And if you are trying to avoid factoring at all costs, that's a great way to do it. All right. We got to move faster, guys. Let's see.
Can I factor out the square root?
Remember, please, no, you can't factor square root. These are past AP questions. So when we sit there and we say, yeah, but this stupid conjugate method is trash and I hate it, it might show up on an AP test. Okay, let me ask you a question. Would you rather question, take the derivative of this or multiply by the conjugate of this?
Derivative.
I'd rather multiply by conjugate. If you want to do derivative, do derivative.
Why would you want to?
Hey, pick your method and go do it. Let's go. So, when I plug in 1, I get 0 over 0, so I have to figure out what that is. And that's what K is going to be. So let's go. Then do L'Hopital's, right?
I don't really know how to do it. I can't remember how to do it.
I don't know what that means. Okay, what's the conjugate mean? It's the opposite, right? So if it's minus, the conjugate would be the exact same thing. Plus.
This was so much. That's so much fun. I remember.
Oh,
It is fun. Thank you, Ben.
I love that.
Okay, I do actually remember that. That's way more work.
All right.
It is, but it doesn't actually matter.
Lit. Okay, guys. Okay. Hey, listen up. This is why I like conjugate. What's a square root times itself? Yeah. What's the outside and the inside going to do every time you have a conjugate? They're going to cancel out. Because I have a x plus root 3 times square root 3x plus 1 minus square root x plus 3 square root 3x plus 1. The entire purpose of a conjugate is the middle cancels out. That's the whole point of it. Okay? Okay. Last term is what? Minus 3x plus 1. Do you guys feel good about what I've written there?
Yes.
You shouldn't feel good about that.
All you did was cancel it out.
But you need parentheses.
Like, you just got rid of the square root.
You need parentheses. How many people would miss that because you'd forget the parentheses? Yup. Probably half the students that do it the first part correctly miss it. That's a parentheses. Because I'm subtracting a quantity, right? So if you're going to get rid of the parentheses, you got to distribute the negative. Okay? Okay, I did the conjugate. This is not L'Hopital's rule. This is conjugate, right? Okay, now. So let's continue simplifying on the top, yeah? Minus 3x minus 1, x plus 3. What do you get when you combine the top? I love it. Now, hang on.
Still gotta take a derivative.
I could take out, oh, you could, or I could just take out a negative 2, and I could see that this equals negative 2. That's a conjugate question. Okay? So when I say, yeah, conjugate, whatever, you never have to do it. I mean, this is how they force you to do something you don't want to do. Or you could take crazy derivatives, but how many of you would forget chain rule right there or whatever? You know what I mean? So
You don't really need to take chain. You can just do the math, and even if you do it wrong, you see that it's like not the right thing.
I mean, hopefully.
Yeah, but if you can do it like moderately wrong,
Oh,
and then you still
this
get the right answer.
blows! And then they give you a none of these. I hate it so much.
No, that's great, because you can get the answer wrong, and then it means you got it right.
But I would doubt myself and be like, no, there's no way, no. End it, man. Just end it. Okay. Oh, this is fun. You guys suck at this. Okay, here we go. Every time we've had a question on a test with an A and B and some kind of system of equations, guess what? You guys never freaking get these right. All right.
Right, we do suck at this.
You guys suck at this. Here we go.
Can I set them
That's why
equal
we're
to
doing
each other?
Yes, but first, this actually might not be that bad. It only has a B, so maybe you guys are good.
25.
It doesn't have an A and a B, so I'm
5b.
chilling. Okay,
5 pi over
the
2.
idea
pi
is
over 2.
if something is continuous, the two sides got to meet up. Yes? All right, cool. Let's plug in 5. 25 plus B times 5.
Mitchell,
And let's do on this side.
Mitchell,
5 sine, yep, 5 pi over 2.
the video can't.
What
The
happened?
video can't see like the top part. It can see
Oh
most of
no,
it.
thank you. Oh, you are so right. Here we go.
It's probably Weston's.
This is my very fancy way of zooming out. Yes, thank you, Weston. Everybody watching the video from home, thank Weston. All right, here we go. Guys, let me tell you where I know you guys might have a little bit of a problem here.
No, because you can just cancel out some of them, and then you
Hey,
go to
do we know what the sine of 5 pi over 2 is?
1.
Is it?
Yeah.
You know. Does everybody else know?
Well, just take out a 2 pi, because the 2 pi is the full revolution.
Okay, guys, let's think about our unit circle real quick. 0, 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2. What coordinate point is that? 1. 0, 1, sine is 1.
Or you can cheat and subtract 4.
Yeah, that's not really cheating, that's understanding. Okay? So 25 plus 5b equals 5. So 5b is negative 20, so b is negative 4. That wasn't that bad, actually, right? No, this one didn't have a system of equations, so that's fine. Oh my goodness. Somehow the multiple choice got cut off on that, but that's okay.
Oh, is there a multiple?
Because it's negative 20 right
Yeah, that one, I don't know what happened in the multiple choice. Somehow got cut off. I don't know.
I did that
Wait,
on the
no.
twist
Oh,
on the tape.
wow. That
That's
one is
disgusting.
0.
It's not. It's so easy.
It's actually
Because it's just going to trick you, make it look like it's hard, but you just look for the exponent.
You guys all got your answer? Okay, first, only the biggest exponent matters, because that's what's going to guide the function, right? 5, 4, 2, only that matters. 6, 5, 3, only that matters. And then I have to check the exponents. And what happens when the bottom is bigger than the top? It's 0. Now, easy dogs, yeah? Huh? Oh, because when you go to infinity, infinity to the fifth is so huge that it like soaks up all the infinity to the fourths and thirds and seconds. So infinity to fifth power is so massive that none of the rest of that matter. Infinity squared is like nothing compared to infinity to fifth. Okay, so remember we talked about this rule where with polynomials, okay, if the top is bigger than the bottom, it goes to infinity. Bottom bigger than the top, it goes to 0. Or if they're equal, we use coefficients. Okay? All right, let's keep moving.
Don't lie. Don't lie to Jada. Let's go to seminary. Just go home.
You don't go to seminary?
I go to seminary. He goes back way more than he goes to seminary. So he therefore goes to seminary.
What time is your seminary?
Hey, guys, I'm going to say right now, this is a really good question. We're going to call these 5 questions, as in the only kids that are going to get a 5 will be getting these things right. Okay? Because the second I look at this, I don't know exactly what I want, but I think I do. Okay? So we're going to do a bunch of limits.
Oh. Oh, never mind.
So kind of we have to do 5 limits, I guess. I guess it's not as bad as I thought, but it's not great. Oh, there, my mic wasn't even on. No wonder I was shouting. Okay. Guys, I do not want you to do L'Hopital's on this because you'd have to do it for every single problem and a couple times, and it's going to take you forever. So let's not do that. Let's think about this real quick. What grows faster, e to the x or x squared? So it grows faster on the top, so it's going to go to infinity. Because there's a bigger infinity on the top than the bottom. It's all about growth rates, okay? Let's look at this next one. What grows faster, e to the x or ln of x? E to the x, that's going to infinity.
Which means you don't even need to do c because you know you just flip it.
You're right.
And therefore you don't.
What grows faster, ln of x or e to the x? And since it's on the bottom, it goes to 0. Boom, done. Because I'm a nervous person, I'm going to do these last two.
No, you're not. No, then you overthink it, and then you pick the wrong one. If you have the right answer.
I get nervous.
No, you're not nervous now. You're just.
Okay, but Mitchell, what would you do? You got 2 zeros.
There's only one right answer.
I don't
You
know.
would take the first right.
Because what if I got another one? Hey, excuse me. Where's Megan? Oh, she left? I was saying, what would Jacob do? That's my new thing. Jacob would check all 5 of these.
He would.
Yes, he would.
Jacob would look at the question and know the answer before he tested it.
You're right. Okay.
You don't actually have to test.
Jacob actually wrote the AP.
My biggest flex is that I got a 5 on BC calculus, so good listening to me. All right, here we go.
And it would get
Well, I got a 5% on the test, so that's even.
Okay.
No, I learned that before.
Population, blah, blah, blah. The population will approach a limiting value. When will the population reach half the limiting value? I don't like this either. Hey guys, what's a limiting value?
That's the more you do it, then we always end up at that number.
Yeah.
Like if it's above it, it's going to go there. Below it, it's going to go there.
Now, if e to the negative means it puts it down on the bottom, and as x goes to infinity, that goes to infinity, and something over infinity goes to 0. Okay, what's the limiting value for this question? 6,000. Okay, hang on. What is half the limiting value? Let's go. All right. When will the population equal that? This is a calculator question. Okay? This is a calculator question.
Z approaches infinity.
Oh, wait, hold on. 6,000 minus.
There are forks in the calculator, far left.
Wait, but it's only spoons and knives.
Uh-oh. Then we ran out of forks, so you know the spoon.
Spoon and a knife.
All right.
Want me to take the receipt or just leave it?
No, definitely leave the receipt.
No, tape it.
Oh, no, just toss it in the top left desk drawer, please. All right. Hey, guys, this is a multiple choice question, which means I don't have to write my steps. If you say them to me and I put them in my calculator, we can do this. If I'm trying to solve for t, what is the first thing you would do?
Set it equals ln.
Plug in 8.
Maybe, no. Subtract 6,000 from that. And I did that on my calculator.
This is y equals. I just about to find it.
Sure, now you're going to have to majorly mess with your window. So that's okay, that's not how I would do it, but you can. You're just going to have to put your window up to like 10,000. All right. 3,000 minus 6,000, what am I going to do next? Divide by negative 5500. What am I going to do next? ln both sides because it's an e. ln answer. What am I going to do next? Divide by, are you out? Are you here? 0. Divide by negative 0.159. And when I do all that, guess what I got? 3.8121. Well, that's crappy. Okay, during which year? Is 3.8 during the 3rd year? Well, what?
Yeah.
Well, would 0.5 be during the 0th year? Like half year?
That's the first year.
So that would be during year 4? Or 3?
Yeah.
That's in year 3 because
I'm not the
If
answer.
you plug in your 4 into the calculator, you get it pretty close to 3,000. It's 3,088. So
So I think it happens during the 4th year.
At the end of it, it'd be the end of the 4th year. When you get to 4, it'd be the end of the 4th year, right?
Yeah. So is it
That would
3
be
or 4?
during the 4th year.
I don't have the answers for this one, so I don't know. This is what we do when we don't have the answers.
Well, if this is a calculator question, we can.
The population of growth, according to the equation, P of T equals.
So it's within the year that is more than one.
If it's a release question, it's going to be on the internet.
The intersection is at 3.8121.
Found it.
So roughly
Okay, this is telling me it's during the 4th year.
there's a 3.
Well, like, think about this, 6 months in, during the first year, 0.5 is the first year, right?
So from 0 to 1.
0.5 is the first year, 1.5 is the second year, 2.5 is the third year, 3.5 is during the 4th year, yeah. Lane, don't like it. That's fine. All right, yeah, we gotta move. Let's go. Yeah.
Last one, let's say you were to just like divide by 3,000 and multiply the x you get for the intersection by 1,000. Would that work?
Say that again.
If you just divide your entire all
All of that for
the 1,000.
what is I-8?
Yeah.
And if you don't know, what you want to
Yes.
It's because 3.81, that's the third year.
Is it a iPhone? That red cord over there? It's like kind of red looking? Yeah. Unless it's the new iPhone with USB-C. Is it USB-C? Thanks, so. Okay. Okay, guys, ready? We gotta keep moving because I want to get through another lesson. Let's go.
Let's do it, Mitchell.
All right. I'm trying.
You know your phone. Not you.
You would skip this one?
No.
Oh, I know. Okay. F of -5 is -3.
Actually, I always have 3.
Guys, f of -5 is 3. Yeah? Okay, f of -1 is -2. If f of x equals 0 for only one value of x, what could it be? Guys, this is something known as the intermediate value theorem, but it's really, if you draw it, this is easy. If you draw it, it's easy. Look, where would it have to cross if it's continuous and a function? Somewhere between -5 and -1. It can't be -7 because that wouldn't be a function, right?
Can't be 1.
It can't be 0 because that wouldn't be a function.
Oh, that's so free.
Easy does. If I see something like that, I'm plotting the points.
I can do that one.
You can do that one. Chris got a point, everybody. Let's go.
1 out of 42. Thank you.
Oh my gosh! Please validate me as a teacher and a human being by all getting this question right, because we literally just talked about this. Please. If everybody in the room gets it right, I will sleep tonight so soundly. Come on, let's go.
Hey, if you get it wrong, just don't say anything.
Miss Mitchell, you're gonna be up all night.
Please, Chris, if you get it right, I'm gonna like.
What if I
So what if I just don't
The
answer
pizza
the
and
question?
everything will have been for a
So
good
what if I
cause.
just don't answer the
Oh, it has
question?
to be.
Would that help you sleep?
All right.
Yeah, so, okay.
Would you be able to
Okay.
sleep if I just didn't
We're
answer?
all gonna say the answer on the count of 3. Ready? 1, 2, 3. E. Let's go. Chris, did you get it? Woo!
I actually thought it was B.
Guys, horizontal oscilloscope from limiting to infinity and half to equal that number. We just wrote this down. I love it. I'm so happy you guys are here. Hey, this is so cool. Guys, They love this function on the AP test. They love it. This is the second time it's come up.
But we just learned what it is because
We
it's
kind of just learned what it is. If you have a lovely photographic memory, just remember what that function is. It's like sine that goes
Look at
up.
this great
and then
drawing of it.
Oh, yeah.
We just did
I
it.
drew it perfectly.
What do you give that? 10 out of 10 or like a
10 out of 10.
Yeah, that's as good as it gets.
But in case you don't remember what this one looks like, look.
What?
If I plug in 0, I get 0 over 0. So what do I do when I get 0 over 0? L'Hopital's. So I get cosine over 1.
Salad, you're not helping.
Down. Down. Down.
I'm just spicing
And
up
what's
the
the cosine of 0? 1 over 1. So k has to be 1 for that to work. Okay, guys, I will put you on a timeout and I'll make you go in the hallway and hula hoop for 10 minutes.
I got lost to go take a walk.
Are you guys good?
Ryan's mad.
Okay, you guys can do this. Ready? 3, 2, 1, go! You guys can do this. No, it's
You have to double check. This is like, are we L'Hopital this or are we factoring? Either way, kind of nice. Yeah, let's just do L'Hopital.
Very good.
So, 2
Great job remembering.
times. Yes.
Are you doing the hard way again?
I don't know.
Oh,
Just derivative.
guys, it's 0. Did we get 0? Okay, let's talk about it. If you want to do it by factoring, cool, like, or just writing that twice. Here's something you gotta be careful of. I'm allowed to cancel that and that, but it makes a -1 somewhere. Okay? You can cancel those, but it makes -1, right? Now plug in 3, and what do I get? 0, because 0 over anything is 0.
Chris, they're technically the same thing, but their signs are flipped. If you were to rearrange that, you could write 3 minus x is the same thing as negative x plus 3. Negative x plus 3 is the exact opposite of x minus 3. So if you were to just divide it by -1, they're the same
I like
thing.
it too much. Okay. All right, guys, listen. Dallin insists on always doing everything a different way, right? Oh my
Yes.
Because
Hey,
he's got-
Dallin!
Hey,
Woo!
that's okay.
Why are you cheering him on?
That's all right. Dallin,
Whatever.
how'd you do this?
Well, I suppose to ignore
Derivative, so you can just do the bottom, and then the top is just
Listen, guys.
-2 the inside.
He said, I'll say it to you in math words. Dallin used Dallin words. I will translate for you. He said, 3 minus 3 over 3 minus 3 is 0, 0. So I did L'Hopital's rule, is what he said. And then he said, the derivative of the bottom is 1. That's what he said.
Dallin,
Now, Dallin,
I understand.
how did you do the derivative of the top? Did you do
I
a
just put it
product
down
rule?
to
Did
2
you do
and
a
then
chain
remember that
rule?
there's a -1. So since it's minus x, you need to bring out a negative.
Did you remember, Ferrari, to put times -1 right there?
Doesn't matter.
I
It's
think
0.
It doesn't matter because it's 0, but what if it wasn't 0?
Then I would have put it.
Okay. And we still get 0.
No, I would, dude. Because in my head, I was like, okay, that's 1. but
Okay,
it's not.
Chris, you ready?
It's not
Bring that down.
-0.
The derivative of the inside because of chain rule. You guys are not leaving, right? So I just have to take attendance for who's here. You go back. Okay. What's the derivative of the inside? -1. And how often is that screwing you guys up on tests and stuff? Very often. Dallin. All right, here we go. Okay.
No, I just don't do my test.
Oh, another ASCO question. Guys, I feel like 75% of you is going to get this. Okay, let's go. Let's do it. Let's go. You got this.
Like every other day.
No.
Me and my brother just switched.
Hey, listen. Based on our discussion, on vertical and horizontal asymptotes. Okay? Based on our discussion, I think
If practice is necessary, we need church.
a good deal you guys are going to get this.
Nobody likes. Everybody just sits the piano. Piano does whatever they want.
One time when my cousins were, their chorus was, they decided to sing. We're doing it?
I think I know.
So every like manipulate, so like
The answer I have.
Ooh, the answer I thought it was is actually not the answer it was. I just rethought it in my head. Okay, I think only 25% of you guys are going to get this.
Wait, what did you think it was?
I thought it was 1, 2, and 3. It's not.
Okay, so it's not E.
Because the first time I read it quickly, and I thought it was like F is positive. And I was like, oh, easy, dude. If F is positive and there's an asymptote of 2, it has to go like that. That's not what it said.
Oh, I got it. Let's go.
It said the derivative of F is positive.
So F prime of X.
Okay. And I have an asymptote of 2. Okay?
I'll feel so happy if I
It
get.
didn't tell me anything about the horizontal asymptote, but let's just pretend it's like right there. You guys. There might not be one.
Okay.
That's okay, too. It don't really matter.
What's going on? I can just add it later.
Okay, guys, let's look at this side of the graph. If the derivative is positive, how do I have to draw this?
The slope always is increasing.
Increasing. Right? Okay?
Well, if the
Let's
derivative
look
is
at this side of the graph, so no horizontal asymptote, I don't care. If the derivative is positive, how do I have to draw it?
It's still increasing.
It's still increasing. Did you? So, the limit as I approach 2 from the left is positive infinity. But the limit as I approach 2 from the right is negative infinity. Because it has to be increasing. Because if I made it go like this, it's not increasing, it's decreasing. So that's true. That's not true because it should be negative. And what's the limit as x approaches 2? It should be DNE. Let's freaking go. I think you are, my guy. Let's go. Don't jinx it. Okay.
I thought it was 1 and 3 for a second because I knew it wasn't from the right, but then I realized if it's not from the right, it's
Yeah.
not.
Does that make sense? Okay. So, Annabelle, think of this. If I've got an asymptote and I'm approaching it, but I have to be increasing, it makes sense that I have to go back. Okay, now if I have an asymptote right here, if I'm decreasing, I would go this way, right? But I have to be increasing. So on the left, it's going up, but on the right, it's going down. See that?
Dallin, stop.
Because in order for this to increase, it has to start down and go up.
Wait, let me see.
Does that make sense? Okay. So the left side goes to positive infinity, the right side goes to negative infinity, the asymptote is DNE, or the regular is DNE. Okay?
Stop.
That is important information.
This is a fun one! Do it! I gotta start marking out who's here. You guys do this. This is a fun one.
Fun one?
This is a fun one. Oh yeah, thank you.
I know.
Let it be known to the record that Isaac is mean.
Alright.
There.
Mark right in here, Mark right here. Where's
Let it
Steven?
also be known to the record that even though Isaac is mean, he's still hot.
Andrew, I saw. Draper? No Draper. Lena Draper? No. Aubrey? No. Lena Hart? 1.5 base times height. Ben, I know is here.
Ben's not.
Dallas here. We gotta bring Garrett. Why doesn't Garrett come? Let's reach out as a friend and bring him. Landon's here.
Raymond asked it last time, and Jared's like, I just chose not to.
Where's Raymond?
That is the magic question. Raymond's not here. Rory's here.
where he lives.
Jacob and Megan are here.
Next time we need to reclaim.
Okay, Megan Kate, we'll give her half.
Was the boys'
Is Carolyn here? No.
What? We need to reclaim that table next time.
Isaac's
I
here.
will. Actually, I won't be here next time. I don't
Maddie's here.
I've been to all
And
of
Abby.
these before.
Yeah,
I know.
Guaranteed.
Zach and Rain are
I don't think I'll
here.
be here. Actually, yes, I will. Plus, it's close to after school.
Where's Jack? Why isn't Jack here? I'd expect him to be here.
He had to work.
All right. I agree. Anna.
Also has work.
Aiden is here. Carly, no.
Wait, was she here for the first half?
I don't think so. Nathan. Sadie, Leanne. Sophie, Jens. No.
Mitchell, can I?
Dawn is not here. Scott's here. Chris is here. Weston's here. Ryan is here.
Who? Always here.
That worked so well.
Everyone else. Literally everyone else.
Lloyd is here.
Lucas Allen, everyone else.
Is Ellie here? Did I see Ellie? No.
Don, you're gonna hit it.
I already did hit it in.
Brock, yes I did.
I wanted you.
Brock, your hair looks amazing today.
What?
Put your eyes in your camera. Give the viewers.
Wait, I gotta go to the Weston, get ready?
Gates here. Annabelle's here. Wyatt.
Yes.
Yeah, Wyatt got here. Let's go. Paige is here. Emily is here.
Fun
What are the
time.
chances of people actually
Lydia's here. Henry is here. Laurel Williams is not here. Harper is not here. Annika is here. Let's
I will.
go. All right.
She sent that to me as well.
Oh.
I mean, you can get it off the stream.
All right.
It's right like this.
It works?
No, it's not. It's not
Okay, you guys ready?
Yeah.
Okay. No. Guys, is the limit as I approach 3 what? True or false? False. Okay, great. The point is 1, the limit is not 1. Very good. Is the limit as I approach 4, 3? No, it does not exist. Is it continuous at 3? No. Is it continuous at 5? Yes.
Don't be a Jacob.
Does the limit as it approaches 6? Excuse me. Don't tell me to don't be a Jacob. Jacob's going to get a 5 and I got a 5. You should all be Jacobs. All right.
It's true.
No, I said, what did it say?
I'm not gonna have enough time to be Jacob.
That's also
I don't have time. I'm gonna find
Guys, the first test we took, Jacob was like just going and going and going and going, and I'm like, Jacob, what's going on? He's like, oh, I'm so sick of checking my answers. I never find any mistakes, but I have to check them anyway. That's so bad.
literally was like,
Because look, it was the integral test, and so he was differentiating every answer to see if he got backwards or what.
Dang it, every single question.
And he's like, I never find a mistake, but I have to do it anyways. Okay, I can relate. There's a very, very important word. Almost done with limits.
No, the European agent's gonna be watching.
Super important word in this is it's an odd function. Does anybody know what an odd function is?
not symmetrical.
Like it's off symmetrical.
It's weird.
Yeah, it's weird symmetrical, okay? So, look, an even function would be like that, right? An odd function would be like that, where it's like symmetrical about the
Because
origin.
the exponent, if the exponent is odd, then
That's right.
it would look like that.
Okay, now we have an odd function, that's all I know. And I know that as the limit as I go to negative infinity is -3.
That was literally you. It wasn't me.
Guys,
It was literally you.
what's the limit as I go to positive infinity on an odd function?
Positive 3.
It would be +3. Because it's odd, so it's like symmetric.
That's what it means.
Yep.
Isaac, did you get all the
Look, if it was an even function, if it went to -3, it would go to -3. If it's an odd function, it flips.
What? I saved some.
Same thing.
Hey guys, shh, listen up. Do we know that there are no vertical asymptotes? I have no clue about that. I don't know whether they are or aren't. Maybe.
Well, it says continuous.
Oh my gosh, you're right. It's continuous. That's true. Let's go, Emily. All right. Very nice. And
You call it Emily?
what did I call it?
I said it.
Or maybe you said it.
Okay.
Emily, you said it, right?
Isaac's phone?
Emily said it also. But I will call Jada Emily if I feel like it. So leave me alone. Because I was making eye contact with Emily and I said, let's go, Emily.
Yes.
But you both said it, and Jada, I also love you. I love you all equally. All right.
You're supposed to hit the head with
Hey guys,
No, that was even cooler.
are they horizontal asymptotes?
What?
That's literally the definition of a horizontal asymptote. 1, 2, 3. Here we go.
Oh yeah, I know.
Don, where did it go?
Oh, I don't know.
I didn't say you. Trust me.
Is that today?
This question is amazing.
Maybe?
I love this
Is there
question.
donuts? If there's donuts, I'll come.
I
I'm
know
not
because
buying.
I'm trying to move fast and I have to talk over all these kiddos. All right.
Don.
Okay, guys. I think that
Oh, yeah, I
this
need
question is amazing and I love it. You guys want to try it?
Yes.
Where'd it go?
Okay. This equation right here will really determine if you have an understanding of what a horizontal asymptote is. All right? Definition of a horizontal asymptote, guys, what is it? Limit as x approaches infinity or negative infinity. Guys, as I approach infinity, what's 1 over x?
You're not supposed to have this. I don't know why.
0. Does everybody understand that? As I approach infinity, 1 over x is going to be 0. Okay.
So just one.
What's e to the 0? 1.
Oh no, never mind. It's one.
1. So what does it equal?
1/3.
1/3. That's so crazy. I love it though. That's really cool. Okay? If you understand the connection between a horizontal asymptote and a limit to infinity, you're golden. All right?
I don't know.
Would it be different if you flip it negative?
There's too many options for that.
No, that's a great question, but 1 over negative infinity was so easy. You don't have to think about that. Okay, you guys. Let me ask you a question. Thank you, Chris. I appreciate that. Let me ask you a question. Am I stellar teaching, or is it just that you're caffeinated, or what?
Maybe it makes them both.
All right, that's fair. Listen.
You're doing really good. I understand.
Thank you, bud. What is a finite number over an infinite number?
0. So just x over
What's a finite number over an infinite number?
infinity over 2 infinity.
The degree of the top and bottom are the same. What's the limit?
1.5.
Let's go. Okay? Now, the remainder of this packet, you're going to do at your leisure, and you're going to check your answers. Take a picture of it. Or write it down, or whatever. Okay? The remainder of Unit 1, what you're going to do is you're going to practice those, and then you're going to see if you get those answers. And if you get, what, half, we're passing the AP test, right?
No.
If you get most, you're getting a 5. Let's go.
We had to get like 2/3 to get 5 or even
Exactly right.
the margin between a 3 and a 5.
No, not that bad. Right, a 4 and a 5, yeah. All right, this one we got a half hour. We might not finish all of Unit 2, but we're going to go for it. We're going to try. There's some pretty cool stuff in here. Hey guys, listen. Oh, I see what you're saying.
It's 20 questions.
You thought we
No,
had
it goes like this. Let's see.
I thought we had to do this.
If you ask for anything,
I feel so bad.
I would have taken 80.
Okay, it goes like this.
You wouldn't have known that I would have taken.
I would have.
Okay, yeah, if you guys want to see what the breakdown is, this will help you a little bit. Okay, check it out.
Guys, wait, excuse me. Oh wait, are you going tomorrow? No, tomorrow will be the last day, and then I'll see you Friday. Okay.
This one he's
Okay,
talking about.
this is the order you'll do it in.
Good, you're just
It goes. Okay, it goes no calculator, multiple choice. You get 30 questions, 60 minutes. And then you get calculator, multiple choice. You get 15 questions, 45 minutes. So the problem is with this one, you have 2 minutes per question.
We have 3.
This one you have 3 minutes per question. And that's why everyone always feels rushed on the calculator part. Not that you even necessarily need a calculator, but you feel a little rushed because, I mean, you feel rushed on the no calculator. This one you have a calculator and you have like days, so people like sit around. And you're not allowed to go back. Is that right? Yeah, because you couldn't go back. So with a calculator, you're not allowed to
go
do that.
back on any
I think there's one that you can, but hold on.
I can't have.
Oh, hold on. So then right here, you keep your calculator out. You do 2 FRQs. And you get 30 minutes. What? Right?
Wait, you know
So
what?
you gotta do an FRQ in 15 minutes. That's how much those are. Then, hang on. Then, you put your calculator away. You do no calculator FRQ. You have 4 questions, and you get 1 hour.
There's no way.
Now, the one thing that you are allowed to do is this. If you finish, you could go back to that because you put your calculator away, so it's not really going to help you. So they do let you go back to that, but you can't go back on the other one. Okay, as far as I remember it.
Just have you do Calc, no Calc.
Look at Mitchell. Her greatest accomplishment is a 5 on the BC Calc.
That was my greatest accomplishment.
I
I mean, I like head kids and stuff, and like, I don't know, like, I got a nice career, but like, I got a 5 on BC calculus.
I want to be like you, Mitchell.
I ran 2 marathons, but still, I think I'm more proud of that 5. You know what I'm saying? All
I
right,
want to be like you, Mitchell.
you should try.
You're my role model.
Not everyone can, but you can try. All right,
We're gonna write and get it like a 15-hour on it.
guys,
I want to be like Jacob.
the thing that you are gonna hate the most,
20 hours.
but if you can get a handle on it, it's really easy.
Walk
Okay.
50 miles faster than
Definition of the derivative. You guys hated it when we started. I know you did, but check it out. Ready?
That's what me and Adam did.
The limit as
They all
h approaches 0.
Yeah. So if you did a marathon and it took you 20 hours, listen. You're going backwards.
I did it in 5 hours and
Yeah, but
27 minutes.
No, we don't like this. This is just the dumb way to say
I
like.
can't read any of that.
Yeah.
Okay, there's one.
Why does it?
Oh, we're just going.
Yeah, I think I could have one.
Is that why we never saw that again? Like we learned the f of x plus h minus.
Yeah.
Like we saw it once.
No, no, we saw it once on a test and never.
Well, just like the limit
Okay.
definition. Of it.
Yeah, we saw it on the test. It hasn't really come up too much. It will show up in multiple choice. Like, it's just going to. Okay?
Arrow.
That's an arrow. Yeah, sorry. My arrow got away from me a little
Limit
bit.
is x plus a.
Okay, so there's 2 ways they could do it. You could take x and x plus h, and you could decrease the distance until they're basically right on top of each other, so h approaches 0. Or you could take a slope between x and a, and you could bring x really close to a until they're basically on top of each other. That means derivative, okay? So check this out. We're on unit 2. Where's my unit 2? All right. So the derivative is, guys, it looks like it's using the h one. Now, this, they're trying to be
I mean, even that looked like.
turkeys because they're using a instead of x, which is annoying. But let's just write it over here. I know it's f of x plus h minus f of x over h. The problem is they changed the x to an a, right? A. Which one is it?
Does.
Which one is it?
The first one.
Limit definition?
Yeah, it's definitely that one. Now I have to think for a minute. It's definitely not this one. But could we write that as number 2? I gotta think about this. Oh, hold on.
I can't do algebra.
That looks like my handwriting.
I think you could do that
That's
too.
exactly how I write an H.
I think I could do it that way too because look, if I take my limit definition, Henry, tell me if this makes sense to you. What if I said, let A equal X plus H? That would be A, and that would be A minus H. Seems reasonable?
I just think it's cool.
I guess you
Right?
could say
You spend too much time. You got other questions to answer.
I would go with that, maybe it's that. I might have to look that one up, but it seems to me like they might be able to tell you. I'm gonna have to look that up. I don't know. Okay? The thing is, instead of plus H here, can I do minus H here? I feel like I can, but I don't know. We'll come back to it. Alright. Guys, this is fun. This is the chapter where we first learned about derivatives. Remember when life was easy and fun and things were good?
Yeah. The only thing we did.
Okay, check it out. Derivative of sine is cosine times 2 because it's chain rule.
Fancy stuff, right?
Derivative of ln is 1 over x plus 1 times 1 for chain rule. Evaluated at 0, I get cosine 0 times 2 plus 1 over 0 plus 1.
Next time when you do derivatives, make sure every time you tell us like ln or something or e to the x, you always do times 1.
Times, well,
I
how do you
always
remember chain rule?
forgot that like for ln's that you do chain
It
rule as
driven the
well.
inside. Yeah, you're right.
It's
I
not just
will.
1 over x.
I'll stretch that chain rule for you.
See?
Cosine of 0 is 1.
It doesn't.
If it's one, it doesn't matter. But if it's negative one, I start to
Exactly.
get mad.
What then? Then what?
from 1 over
Even if it
0
doesn't.
plus 1 to 2 plus 1.
Because the cosine of 0 is 1 times 2.
My bad.
Okay,
What do you do?
how about this one, guys? Derivative of an ln, what's the derivative of ln?
1 over x.
1 over cosine 2x. Okay, guys? What's the derivative of cosine?
That would be sine.
Negative sign.
You good if I put it on the top? Derivative of cosine is positive sine
Okay, so it is
2x. What's the derivative of 2x?
2.
2.
Isn't that just 2 tan of 2x?
Yep, what's sine over cosine?
Oh, that's what it's asking. Whoa.
Hey, how did you get positive?
Derivative of cosine is negative sine. Jeez, I just had a stroke. I was like, nope, you're wrong.
Fair.
Derivative of cosine is negative sine. I don't know what's wrong with me. I'm going to blame the fact that I work too much. Alright. And I do this full crap for you because I like you guys. I could be home watching TV right now. I could be taking a nap. I know, but you're getting something out of it. You're getting a 5 on the AP test. What am I?
Isaac is?
Huh?
Did you say Isaac is going to get a 5?
My second greatest accomplishment will be as soon as I get my AP pass rate up to like 90%. That's not gonna happen this year, but I'll get it. Oh, no, it's not.
That's going to require you specifically admit students that you.
Which I know. You're right. Okay, you guys ready?
0, 3, gun, bam.
All of your calc students passed.
Oh, we would have the biggest, it's not gonna happen, but we would have the biggest party.
Sell your house.
Dude, we did so much.
You saying you don't have faith in some people in our class?
You and me both.
Guys, oh, not BC, I'm talking about like 80s.
Well, technically some people.
No offense,
Why do you
Jada.
think she's doing these after school things? It's for us, not for you guys.
No, it's for them. No, everybody who's here, every single person here has the ability to pass. No problem. You're not the people I'm worried about.
So why am I getting a 5? If I
Okay,
get a 5, then I wasted my time.
guys, not differentiable at a sharp corner at a hole. Okay? Alright. Oh my goodness, friends, what does instantaneous rate of change mean? Derivative. You guys have learned something.
So 2,
I feel like you're actually learning things
minus 3
sometimes.
I think that, and then I leave and forget everything.
0, cosine 0, 1, negative 3.
Right? So e to the 2x times 2. 3 stays in front, cosine x.
Calculator.
Oh, you don't need a calculator for this.
Oh, it's 0. I forgot. I was gonna plug in.
Okay,
So 2.
what's e to the 0?
3.
1. 2 times 1 is 2. What's cosine of 0? 1 minus 3, negative 1.
I got that, and then as soon as you asked for it,
Hey,
I
guys.
suddenly said
Knowing that these are past multiple choice questions, are you feeling a little bit more confident?
no.
They're not that
Well,
bad.
are these past AB multiple choice or BC? Because I know the tests are a little different.
You guys will be fine. We'll go over other stuff. You're chilling.
Not really, but.
Okay, the function is continuous. Which of the following statements could be false? Hey guys, if it's continuous, does the limit have to exist if it's continuous? Yeah, it does. That's like literally the
The
definition.
limit just means that there's stuff to both sides of it.
If it's continuous, does the limit have to equal the point? Hey guys, that's the definition of continuous.
There's a limit for every single point.
If it's continuous, does f of c have to be defined? Yes. That's the point. F of c is the point. It has to be there. Does the derivative have to exist?
No. You can check that one first because you know that sharp corners kill
Yep.
derivatives. And then
Look, counterexample right there. The derivative doesn't exist, but it's continuous, okay? That's a good
because
counterexample.
I wouldn't want to think through the other ones, but if you see f prime,
Okay, guys, more vocab. You ready? What is average rate of change?
Slope.
Slope. What is instantaneous rate of change?
Derivative.
Derivative. This tells me this is a calculated question. Okay?
yeah.
And I need to know where slope equals derivative.
Oh wait, there's a.
Okay?
Is there a theorem thing for that?
Oh, heck yeah, that is the mean value theorem, actually. Very good. Okay. Now, let's plug in 0 and 3. If I plug in 0, I get 0 minus 1. I get negative 1. If I plug in 3, I get... Oh, you gotta be kidding me.
Hey, oh, it's calculator. So 1 over e to the third. 1 divided by.
Yeah, if I plug in 3, I get
0.04978706.
9 minus 1 over e to the third. Right?
Cheating method also works.
Fine. Okay. You guys ready? Grab your calculators. I'm going to grab a calculator. We got to do a little bit of calculator stuff. You do got to pay attention if you want to pass. That is great advice. Really good advice. Right? I know, it's because I'm trying to do 2 units tonight. Because I just wasn't able to come up with enough days. But here we go.
You know the passcode to this thing?
Hey guys, I just thought of something. I just thought of a way better way to do this. Okay, check it out. In y1, I'm going to write my equation. Okay? X squared, what is it? X squared minus 1 over e to the x. I'm going to use the fraction button.
It's over. Why? Is there?
Okay. Guys, I know you're squirrely, but let's go. All right. In my second derivative, in my y2, I'm going to graph the derivative. Okay?
That's kind of what I was working.
Do you guys remember how to graph the derivative?
Okay, you just hit the derivative
Like
function
this.
and y1.
Math 8 dx.
Alan, is that you?
Okay? What's up? I go to alpha trace y1
It's recorded.
Oh.
and Isaac, x equals x. You guys see that?
We're not doing the derivative. Oh my goodness.
Alpha y equals.
Oh no.
Alpha and then that button on the top.
Oh my window.
The alpha y equals. I know it helps so much.
I know.
Now guys,
We're just gonna, we're not even.
let's say, guys listen, I was calculating that up there and I was thinking to myself, Self, you're being really stupid right now.
This is what you're thinking?
What?
This is your thinking up here?
That's it. Okay. Look guys,
You should let me see the hyperbola.
I'm gonna turn that off. I only want to see the derivative, okay? I'm gonna turn that off. You can ignore it, but I'm just gonna turn it off. Now,
How did you turn it?
you just enter on the equal sign. Okay, now, you guys, I want a way to type the slope in here without having to type the slope in here, right? And what's the slope of any line? y2 minus y1 over x2 minus x1. You guys, this is going to be so cool. Check this out, okay? I just thought of this. Look. Make this as a fraction, and then go alpha trace the y coordinate of 3 minus alpha trace
The poor calculator.
alpha y equals minus the y coordinate at 0, and what do I put on the bottom? What goes on the bottom, guys?
3 minus 0.
Hey, that's the slope right there. Down. Sit your booty down, kid.
Bro, Isaac's a super villain now.
Do you guys see that that's the slope? And the slope is numeric. Now, could I have figured out the slope and put in a number? Yeah, but this makes me look so much smarter, right? I think.
What's your I'm just on Zoom 6. I was just like, let's just do Zoom 6 because that's easier.
Now, guys.
Oh, this is taking forever to graph it. Why do you take so long? Hold on.
Miss Mitchell, how come your graph's so much faster?
Because it's on my computer. You're welcome, guys. Okay, now look. I'm going to calculate intersect. There's 2 spots, you guys. How do I know which one to go to?
Whatever one's in the interval.
Whatever one is in the interval, and the interval is 0 to 3, so I'm going to go 1, 2, 3. And guess where my intersection is?
Someone stole your iPad.
Because that's L2. I don't know what that is.
Both options are.
You took an L, man. There you go. Yeah.
Wait, what's it asking?
Okay, guys. 1.552. And you? Guys? Wait.
So at 3.
I mean at 1.553, yeah.
Wait, so are we just trying to find
It's at X.
Yes.
my graph looks, I think this is way more confusing, man. Wait, where did that third thing come from?
Only because we had to use the calculator to solve it. That's all. We found the derivative, we found the slope, and we set the equal. We just had to do it on the calculator.
It's so long.
The equation would be when f prime of x is equal to, then use the slope equation.
Yeah.
I know.
Okay.
Yeah.
Okay, guys, I want to move on because we're running out of time, and I want to do some more of these. Ready?
Well, my calculator takes 5 minutes to draw one.
Yeah, that's not good. Okay.
Miss
We will check calculators before the AP test.
I used the calculator and I did not get that.
Then you typed something in wrong, but I'll show you later. All right, guys, what does slope of tangent line mean?
Derivative.
Derivative.
So this is the derivatives and then evaluating the height.
They knew that.
What did you do to this calculator?
Okay, you guys good?
Jada, things are
Okay.
happening.
What's another way of writing x to the negative 1/2?
Wait, minus y1 equals x minus x1?
Yes, but we only want the slope right now, not the line. Only the slope, and the slope is derivative. Yeah, we only want m.
See, this is why you hate.
Now, you guys, that's exactly right. What does x to the negative 1/2 mean?
Wait, does the 1 even matter right now?
Not yet. Okay, that's my derivative, right? Now, what am I plugging in for my slope? That. The 1 actually doesn't matter at all.
So we didn't even need it, because we
No.
just needed to take the derivative and plug it into e squared.
Now, if we had an equation of a tangent line, yeah, it'd be y minus 1 equals mx minus e to the 2. But this one only wants m. Yep. So if I put in e to the 2 here and here, what's the square root of e squared? E. 1 over e, 1 over 2, 1 over e. Right. I almost put that. 1 over 2e squared.
What did you almost put, Mitchell?
I almost put that because the 2 messed me up. Such an L. You're right. Such an L.
That's a D.
I almost added the e's and got
Right.
Oh, because you know, it's chain rule.
Man, I know the answer to this, but I don't know how to explain it. Okay. All right. Guys, continuous means there are no holes or anything in the graph. First of all, let's cross out the ones that are not continuous. Now, the time that we have problems with domain and continuity, there are two things I look for. Dividing by 0 and square root of a negative number. Okay. Can any of these divide by 0 or square root of negative? B, if this is, yep, if it's in the interval, if it's 0, it's square root to negative, so that's bad. Okay, what else? Could this divide by 0?
Yeah.
Okay, those are not continuous. Now the other two are totally continuous. They are totally continuous. Guys, listen up. If you've reached maximum capacity, you're welcome to go, but I'm trying to get through a few more here. Okay. Do you guys have any idea of what that might look like?
Well, if it's an absolute value, it should be mirrored.
Yeah, now, look, without the absolute value, what does that look like?
Oh, that's a bit
Okay, when you put an absolute value on something, you know what it does?
Oh, wait.
Flips it to make it positive. Whoa. Oh, I
It's that. So, my problem is that this is not differentiable because of the sharp corners. It's continuous, but it's not differentiable. That's my one. That's my one that's good. Okay?
But aren't you going to check your work like you...
Yes. I'm going to check my work because I actually know what this makes. Do you know what that makes?
Well, a square root just goes Q, but then if
Hey,
you
hold on.
have a 2, then it just kind of like an X.
Y squared is x squared plus 1. This makes a
circle.
ellipse.
I was closer than I thought I would be.
But only the top of an ellipse.
Yeah. Oh my gosh.
That's technically...
I think it makes that.
Well, what's the boundary
Oh,
of the
it's
ellipse?
an arc.
Oh, yeah.
No, that's not what it does. I'm lying. It goes
Well, if you take
like
a...
that.
It's a way.
That's my guess. Let's see if I'm right. If I'm right, you will all bow to no. Don't. This is your.
Square root.
That's not what it
X squared plus 1.
That's -1.
That's not it, yeah.
Dang it. I was wrong.
It was still a parabola?
Yeah. Oh yeah, it's a hyperbola, but it's an up line. Yeah, okay, I was
Wait,
wrong.
it's a hyperbola?
It's whatever.
Wait,
Okay.
hyperbolas.
That's what I'm getting. Okay, I'm having a brain fart moment.
All right, so real quick, let's get through a couple. I really want to get to this question because it's super, super interesting. All right.
It's a what?
At how many points on the interval -2 pi to 2 pi does the tangent of that have a slope of a half. Tangent means derivative, right? Let's take the derivative of that. Derivative of the first second plus first derivative of the second. That's negative sign. This has to be a calculator question.
I don't think it has to.
Just
Oh, no, he does, because you can't really find the sine or cosine of those.
I think this has to be a calculator question.
Because you can't find.
Cosine minus x sine x. Yeah, I'm pretty sure that has to be a calculator question because you take the derivative, which was cosine x minus x sine x. And you say, when, that's cool.
That's like the other one, but cooler.
Ooh.
I've seen this. I remember that.
You like that? Okay? And we set that equal to pi over 2. That'd be crazy.
Oh.
And we restrict my interval, right?
Yeah, because otherwise there's too many.
If I go by pi over 2, and I just look from negative 2 pi to 2 pi,
You still have
how many times?
0.
1, 2,
4.
3, 4. That's right, 4 times. That's a calculator question. That's
Oh,
calculator.
that's asking something different. I bet you could.
Okay, guys, I really want to talk about this. All right, when you see that, okay, what's up? Does this make you think definition of the derivative? Okay, it should.
Yes.
Okay, guys, definition of derivative. Now, you're going to identify two things. What's the function that I'm using, and then what number is it at? So hang on a second. What function is this using? I mean, there's like a 3, and there's like a 5th. What function is that?
That would be 3 to the 5th.
That's right, 3x to the 5th. We are replacing, pretend like that is my function, okay? You're good. Right? But wait, can you watch this one part before you go? Okay, here's the school. So my function is 3x to the 5th. Do you guys all believe me?
Yeah.
And what number is it plugging into my function?
It's
At x equals 1/2.
yes.
So that's the definition of the derivative of that at a half, okay? What's the derivative of 3x to the 5th?
That would be 15x to the 4th.
And if I plug in 1/2, what do I get?
You get
No, it's
something 15/16 done.
4.
Boom, done. See how cool that is?
Yeah.
So all you had to do, you guys, was you had to check and figure out what the function is and what the number is, and then just do the derivative, okay? It's just a weird way of saying take the derivative of that.
They won't ask you to do any of them in the limit definition on the test. Please.
No, not on the FRQs. Let me just see if I can find one more of those, and then we'll call it. This one.
Okay.
Guys, is this a limit question? It's actually not a limit question.
Yeah, I was like, this is like a derivative question.
Look, that question, what is that? You recognize it? That's the definition of the derivative. So what is it telling me to do? Take the derivative. That's it. Make sense?
Yeah.
So, I flipped ahead a little bit. So instead, you guys, instead of saying, find the derivative of, boom, it gives you that crap. But when you see that crap, I want you to say, oh, that's the definition of the derivative. And then I want you to say, what is the derivative of this? Boom, done. Okay, you guys see how fast that is? Alright, let's call it good. Really, no, or?
Yeah.
Okay. Yeah. When you see this big, ugly limit as h approaches 0, fx plus h minus fx over h, that means definition of derivative. So what I want you to do is you can cross that off and put find derivative. What's the derivative of that? Derivative of x is 1, derivative of cosine is negative sine. That's it. Okay? We'll do more of Unit 2 next time. Hey, look, if you want to start the answers for Unit 2, though, let me give you the answers for that. Okay, take a picture of that if you want. That's the answers for Unit 2. Alright, you guys are awesome. We got one more in the books, baby.
Overpowering the goodness of a skill, or just a morality overpower? Like, it's a good, like, being good at a skill.
Hey guys,
right?
no ACT this weekend.
Yeah.
And our next AP thing is next Wednesday. So take this time off to saturate your brain.
It's not really like you're a good person for not doing something. You're not like a good person for not doing something.